Hello, this is Prakash. This short video is going to present you the concept of fully polynomial randomized approximation schemes. Before we understand what do we mean by Fpras, let us dissect the components as fully polynomial randomized approximation schemes, and let us see what is the correlation between them. Let's not get into the double details of the concept, but let's see all the correlated concepts which would be related to the concept of Fpras. The idea in the next few slides is to see the mathematical notation and understand the logical interpretation. So let us start with approximation scheme. Going by the general definition of approximation scheme, we just want to approximate answer. I have an input, I know what the output is, and what I expect is an output which is closer to the expected output. Moving on to the next one, let us see what is a polynomial approximation scheme. A polynomial approximation scheme, well, here the aim is to make the solution to be in polynomial time. So what we say is we have a constant real number epsilon, and I want my solution to lie within the range as described by the equation. That is, I have an upper bound, I have a lower bound. Getting a solution in this time is going to make my solution into a polynomial one. Let us move on to the next one, which is a fully polynomial approximation scheme. So we have just added one more prefix to the previous one, which is fully polynomial. Put a neater definition to the solution by saying that my solution is now bounded within n and 1 over epsilon, where the rest of the conventions remain the same as what we had discussed in the previous definition. Moving on to the next one, what we have is a polynomial randomized approximation scheme. Well, what makes this definition interesting is that we have a bound solution which is supposed to be in the polynomial time, and now we say that that's going to occur with a probability of delta. And in the represented equation, we have represented with a delta as 3/4. Let's move on to the final interesting definition, which is nothing but a fully polynomial randomized approximation scheme. So here comes the greater devil. This is what makes the concept interesting. We have seen a polynomial randomized approximation scheme, and Fpras is putting a bound to it and say that this is what is the range which I expect my solution to be. Well, what we have is this definition of Fpras, putting them all together, and how is it different from a Pras than Fpras. No concept is celebrated without its applicability. Let us see what are the areas in which Fpras finds its application and makes its contribution. We are going to pick one of the famous applications, which is Hamiltonian cycles, where we define the task. The task here is pretty much quite simple, which is nothing but counting the number of Hamiltonian cycles in a directed graph. The idea is to use the sequential acceptance or rejectance so that we approximate the total number of perfect matchings. So the idea totally comes up from the Fpras technique. With this approximation technique, it is found that the algorithm runs in the expected efficiency of n raised to 8.5. However, this also improves the Markov chain Monte Carlo method, which diverses once again the range of applications where these techniques can be used in. Let us see another similar kind of application, which is nothing but the network reliability problem. The task here is to determine the probability that the network becomes disconnected due to the edge failures. Using the Fpras technique, the idea here is to estimate that probability within the relative error of 1 plus or minus the epsilon. This finds out a wide variety of applications in the design of communication networks. Let us look at the major takeaways. So this clearly says that you can find out an Fpras for accounting if and only if you find out a polynomial time algorithm for uniform sampling. So that's one of the most significant results which we can use of. Similarly, we have another takeaway, that is, for a self-reducing counting problem, either there exists a Fpras or there doesn't exist a polynomial time approximation algorithm. With the assumption of gratification, thank you.